mastermind presents numerical solution of Laplace equation. Before watching this video, please subscribe and click on the bell button.
Numerical solution of partial differential equation is very important in numerical methods. Here we are going to see numerical solution of elliptic equation, parabolic equation and hyperbolic equation. Best example for elliptic equation is Laplace equation and Poisson equation. Laplace equation is represented by dou square u by dou x square plus dou square u by dou y square is equal to 0. And Poisson equation is represented by dou square u by dou x squared plus dou square u by dou y squared is equal to f of x comma y. Here we are going to see the solution of numerical solution of Laplace equation by Liebmann's iteration method. So the iteration method is very important to solve the Laplace equation. Also the Laplace equation is denoted by uxx plus uyy is equal to 0 or del square u is equal to 0. Del square represent Laplace operator. So using the Liebmann's iteration method, we have to consider the square mesh. It represents a jth line, it is j plus 1th line, it is j minus 1th line. Similarly, the vertical line consider as, suppose it is considered ith line, it is I minus 1, it is I plus 1. So we represented by point u. U is the solution of Laplace equation. So each point is represented by according to the x value and y value. X value taken along the x axis and y value taken along the y axis, and I and j are represent the step size of x and y. So here u I comma j minus 1 represent x is equal to I, y is j minus 1. Similarly, in left hand side of this is u I minus 1 and j minus 1. The right hand side of ui is u I plus 1 j minus 1. So here x is I, the step size is increased by 1, that is x value is I plus 1. Similarly, here x is I, the decreasing one value from I, that is I minus 1. So u point represented by according to x and y. So it is represent u I minus 1 and j minus 1. It is u I j minus 1. It is u I plus 1 comma j minus 1. Suppose we are going to next line, that is the increment of j. So here j minus 1 becomes j, that is u I j. This side it will become u I plus 1 comma j, and left hand side it is u I minus 1 comma j. Similarly, you go to the next line, that is j is increased by 1, it is j plus 1. So it is u I comma j plus 1. Throughout the vertical line, x takes the value I, j is j minus 1 here and j plus 1. Similarly, right hand side of u I j plus 1 is u I plus 1 comma j plus 1. The left hand side of u I j plus 1 is u I minus 1 comma j plus 1. So using the square mesh, we are finding the two formulas, that is one is standard 5-point formula, another one is diagonal 5-point formula. So I need u value at a point x is equal to I, y is equal to j. We have to consider the surrounding grid point value u I comma j plus 1, u I minus 1 comma j, u I plus 1 comma j, u I comma j minus 1. So using that we can find what is the u value by using standard 5.5 formula. So we will see what is the standard 5-point formula. Similarly, suppose I have to use the diagonal 5-point formula, that is we are considering the diagonal points u I minus 1 comma j plus 1, u I plus 1 comma j plus 1, u I plus 1 comma j minus 1, u I minus 1 comma j minus 1. To our convenient, I am taking the points A, B, C, D for the standard 5-point formula, and diagonal 5-point formula I am considering this point as E, F, G, H. From square mesh, standard 5-point formula is u I comma j is equal to 1 by 4 times of u I minus 1 comma j plus ui plus 1 comma j plus ui comma j minus 1 plus ui comma j plus 1. That is, the corresponding x value is I and y value is j. U is equal to 1 by 4 times of left hand side of u value and right hand side of u value plus vertically above the point of ui comma j, that is above point and below point, that is equal to 1 by 4 times of a plus b plus c plus d. Similarly, diagonal 5-point formula is ui comma j is equal to 1 by 4 times of ui minus 1 comma j plus 1 plus ui plus 1 comma j plus 1 plus ui minus 1 comma j minus 1 plus ui plus 1 comma j minus 1. That is represented by the point 1 by 4 times of e plus f plus g plus h. The diagonal 5-point formula is used to find only initial value. Remaining we continue with the standard 5-point formula. Consider an example given that u of x comma y satisfy the equation del square u is equal to 0 and the boundary conditions u of x comma 0 is equal to 0, u of x comma 4 is equal to 8 plus 2x, u of 0 comma y is y square by 2, u of 4 comma y is equal to y square. Find the value of u I comma j, where I takes the value 1 comma 2 comma 3 and j is equal to 1 comma 2 comma 3, correct to the two places of decimals by Liebmann's iteration method. So these are all given boundary condition of u of x comma y. So u of x comma 0, that means y is equal to 0. Along x axis different value of x, u value is 0. Similarly, y is equal to 4, x takes the different value, then u value is equal to 8 plus 2 times of x. U of 0 comma y represent when x is equal to 0, different value of y, u value is y square by 2. U of 4 comma y is different value of y and x is equal to 4, u value is y square. So what is you are going to find? U of I comma j, where I is equal to 1 comma 2 comma 3. That means the step size of x is 1, that is first x I is equal to 1, I is equal to 2, I is equal to 3, and similarly step size of y is 1 when j is equal to 1 comma 2 comma 3. So we are going to find what is the u value at a point 1 comma 1, 1 comma 2, 1 comma 3 and 2 comma 1, 2 comma 2, 2 comma 3. Similarly 3 comma 1, 3 comma 2, 3 comma 3. So different value of x, different value of y, what is the u value? By using Liebmann's iteration method. From problem given, u of x comma 0 is equal to 0, where x range is 0 to 4, u of x comma 4 is equal to 8 plus 2x, where x range is 0 to 4, u of 0 comma y is equal to y square by 2, the range of y is 0 to 4, u of 4 comma y is equal to y square, range of y is 0 to 4. Here we considering the square mesh of the unit length is 1 along x-axis and y-axis. Consider the x-axis and it is the y-axis. Then different value of x, that is x is equal to 1, 2, 3, 4. Similarly, y is equal to 1, 2, 3, 4. I am here writing as pointed as a u value. Given boundary condition u of x comma 0 is equal to 0, that is the u value at a point when x is equal to 1 and y is equal to 0, u value is 0. Similarly, x is equal to 2 and y is 0, u value is 0. X is equal to 3 and y is 0, that is u value is 0. Similarly, along y-axis, the given boundary condition is u of 0 comma y is equal to y square by 2. Suppose we consider the point here, coordinate points, that is x is equal to 0, y is equal to 1, then 1 square by 2 is 0.5. Similarly, your coordinate point is 0, 2. 2 square is 4. 4 by 2 is 2. That is u value. Similarly, your coordinate points is 0, 3. Then the u value is 3 squared by 2. That is 9 by 2. That represent 4.5. Here 0, 4. 4 square is 16. 16 by 2 is 8. Now consider the x-axis which is parallel to y. Now consider x is equal to 4 which is parallel to the y. It represents the line x is equal to 4. So this point is considered as x is equal to 4, 4, 1. At a 4, 1, the value of u is given as 4, 1 is equal to 1 squared. 1 squared value is 1. Similarly, here the point is represented by x is equal to 4 and y is equal to 2. Then the u value is y square, that is 2 squared, that is equal to 4. Similarly, here y is 3, x is equal to 4. Then the u value is y square, that is 3 squared, that value is 9. Similarly, here 4, 4, y value is 4, the corresponding u value is 4 squared, that is 16. Now using the boundary condition, I fill the u value along x-axis and y-axis and x is equal to 4. The remaining one is y is equal to 4. Different value of x, that is given u of x, 4 is equal to 8 plus 2x. Now here it represents y is equal to 4 and different value of x, the given function is 8 plus 2x. That is, here y is equal to 4 but x is equal to 1. If x is equal to 1, 8 plus 2x is 10. Similarly, x is equal to 2. 8 plus 2 2s are 4, that is 12. Similarly, this point x is equal to 3. 8 plus 3x is 6, that is 14. Similarly, x is equal to 4. 2 4s are 8. 8 plus 8 is 16. Now, using the boundary condition, I fill the boundary of the square mesh. U value is along x-axis, along y-axis, and x is equal to 4 and y is equal to 4. Now intermediate point is given as u11, u2, u3, u4, u5, u6, u7, u8, u9. So these are all the unknowns. So if I have to find u1, u2, u3, u4, u5, u6, u7, u8, u9 value by Liebmann's iteration method. From square mesh, we are going to find first u5. Suppose we are going to find u1. I am taking standard 5-point formula. These 4 point. Then u2 and u4 are unknown. So I am unable to find what is the initial value. Similarly, suppose I am taking the diagonal 5-point formula for u1. The 8, u5, 12, 2. So again u5 is a unknown. So we have to use standard 5-point or standard diagonal formula. We need the initial value. So first I have to find here u5. Intermediate mesh, everything is unknown. So I am going to the outermost grid. All are the known values. Suppose I have to find u5. I have to consider the standard diagonal 5-point formula. Therefore, u5 is equal to 1 by 4 times of 12 plus 4 plus 2 plus 0. Why we are not taking here intermediate grid? The innermost grid is all are unknowns. So I am going to the outermost grid. Here all the values are known. Therefore I am using the standard 5-point formula to find initial value of u5. Therefore the u5 is equal to 4.5. Once I know u5 is 4.5, then to find u1 I have to use diagonal 5-point formula. Suppose I am using the standard 5-point formula, the u2 is unknown and u4 is unknown. Therefore, in this case, first to find the initial value, I have to use the diagonal 5-point formula. Therefore, u1 is 1 by 4 times of 12 plus 8 plus 2 plus u5. The u5 value is already we know that 4.5. So using that you are finding the initial value of u1. Next I am going to find initial value of u3. Why I am not going to find u2 value? Suppose we are using standard 5-point formula or standard diagonal 5-point formula. u2 is equal to 1 by 4 times of u1 plus u3 and 12 plus u5. Here I know that u1, u3, again the u3 is unknown. Suppose I am taking the diagonal point formula for u2, again here u4 is unknown. So that's why I am choosing u3 initial value by using diagonal 5-point formula. I am taking u3, so I can't use standard 5-point formula because u2 is unknown, u6 is unknown. I can use diagonal 5-point formula. Already we know what is u5. I know 16, here known value is 12, 9. Therefore, the u3 is equal to 1 by 4, 12 plus 4 plus 16 plus 4.5, that is 9.13. Similarly, I am not going to find u4. Next u7. Because if you find u7, you know the diagonal values u5, 0 and 0 plus 2. So, u7 is equal to 1.63. Similarly, I am going to find u9 by using diagonal 5-point formula. That is u9 is equal to 1 by 4 times of u5. I already know that 4.5 plus 0 plus 4 plus 0, that is equal to 2.13. Once I know the initial value of u1, u3, u7, u9, next I am going to find what is the u2. So for u2, either you can use diagonal 5-point formula or standard 5-point formula. First we will try standard 5-point formula to find u2. u2 is equal to u1. Already we know that u1 value, and u3, u5, u12. Better result we have to use standard 5-point formula. Now we know u1, u3, u7, u9 and u5. Now we are going to find the remaining value u2, u4, u6, u8. To find u2 by using standard 5.5 formula. u2 is equal to u1 plus u3, 12 plus u5. So here u4 is unknown, here 14, 10, u6. So I can't take diagonal 5-point formula to find u2. So surrounding point only standard 5-point formula you can use to find u2, only standard 5-point formula, because we know the value u1, u3 and u5. So standard 5-point formula for u2 is equal to 1 by 4 times of u1 plus u3 plus 12 plus 5, that is 8.04. Similarly for u4, 1 by 4 times of u1, u5, u7 plus 2, that is 3.69. u6 is equal to 1 by 4 times of u5 plus u3 plus 4 plus u9. Similarly, u8 is equal to u5 plus u7 plus u9 plus 0, that is 2.07. So these are initial value of u1, u2, u3, u4, u5, u6, u7, u8, u9. Hereafter we are using only standard 5-point formula to find the convergence value of u. So fill the points. u1 is equal to 6.63, u5 is 4.5 and u3 is 9.13 and u9 is 2.13 and u7 is 1.63, u3 is 9.13, u5 is 4.5. Similarly, the initial value of u2, u4, u8, u6 are 8.07, 3.69, 4.95 and 2.07. Now you know the initial values of u1, u2, u3, u4, u5, u6, u7, u8, u9. Hereafter we have to find convergence value of u by using standard 5.5 formula. So again I am starting from u1. So u1 is equal to u2 plus 10 plus 4.5 plus u4, that is u2 is 8.07 and 3.69. Then you will find new value of u1 is 6.57. Next we are going to find u2. To find u2 value we are using standard 5-point formula, that is u1 plus 12 plus u3 plus u5. Here notice that we are taking for u1 value is new value, that is 6.57 plus 9.3 plus 4.5 plus 12 divided by 4, that is 8.05. To find u3, again we are using standard 5-point formula, new value of u2 plus 14 plus 9 and u6 is equal to 4.95, that is 9.00. To find u4, new value of u1 and u5 2 plus u7. So you're getting 3.68. Continue the same process to find u5, u6, u7, u8, u9. You're getting the value 3.68, 4.69, 4.94, 1.56, 2.10, 2.00. So again we have to continue the process till to get same value of u1, u2, u3 up to u9. Again we are going to find u1 using the latest value of u2, u4 and 4.5 plus 10. That is u1 is equal to 1 by 4 times of 8.05, 3.68 plus 4.5 plus 10, that is 6.56. It is the second iteration. Similarly to find u2, u3, remaining all the values. At last after fourth iteration up to 2 decimal part, it is same as third iteration. So u1 is equal to 6.57 and previous iteration value is also 6.57. So we continue the process to get up to same value of u, that is u values are convergence. Therefore u values are convergence at a point. u1 is equal to 6.57, u2 is equal to 8.07, u3 is equal to 9.0, u4 is equal to 3.72, u5 is equal to 4.70, u6 is equal to 4.93, u7 is equal to 1.57, u2 is equal to 2.07 and u9 is equal to 2.0.
Hope this video is useful for you. Please subscribe and click on the bell button.